Yo. So finally unstaked my coins. I got a little error when I was staking, and let's see. It was quite the adventure. Let's see if I can find the post where it started. But so I had unstaked, um, and someone else was having the same issues with their wallet, where this function call wasn't able to resolve, and someone actually fixed it a couple hours later, um, and they said that they had made the change and it was resolved. And I was like, well, I was thinking, when does the change hit mainnet, right? Because I figured they'd have to push the change or something to update, but I just went into incognito mode, went to my wallet, and it was already fixed. So, if you're having this issue, just make sure your wallet's not cached, and uh, you know withdraw your funds. Um, but it worked. Um, oh, look. Hey, I had that problem too. I just uh, mistaken in a private window. Make sure that it at yeah, and so I bought some NFTs. I really think these are cool. I like these TV boys. Of course, TV boy, uh, kind of like Fully Cooley or something like that, right? I'm sure there's other television robots, television head robots, but Fully Cooley is what I think of, and so I think these are neat. So I got one. I got those free ones. They're still free. Um, there are lots of free ones actually, and I might spend some time just looking at NFTs because why not? They're cheap. Get them while they're cheap before the price goes up, right? When the price goes up, then who knows how much these are going to cost. I mean, you know, that's part of what's so appealing about Near is the price is right. I mean, so far, I've been doing this sort of learning how to program in Near for about a week, and it's just been there have been problems. There have been this blockchain has been. I mean, I've had issues, right? Like testnet went down for like hours one day, and today there's an issue with the wallet where you couldn't unstake. I mean, that it's only been 7 days, and those are two huge problems. So I don't know. Maybe they're not as big as I think they are, but from a usability standpoint, like that's some beta type of stuff right there, right? That's like they're in test still, you know. So that's interesting, but yeah, I mean, but I like Paras. I think it's cool. I think these websites are reasonably fast. I think the blockchain's reasonably fast. I don't know how much that changes um, when people actually start using it, right? Because I was looking, this the stats are really interesting, right? Like if you go to your wallet, oh yeah, and I found this. uh, chain punks. I'll get some chain punks. I got 5 of them, and you supposedly can only have 10 per wallet, but you know, this is a reasonable price for this. You know, so we get another one, a buck 83. Oh yeah, that one's cool. I got oh that's my first like mostly red one. I like I like this one the most, honestly, but and this reminds me of kind of like just anything you collect, right? Like, it's fun. It's fun. I mean, it's just that's a sick one. I like that one. Yeah, without the beard. It's blue without the beard. Yeah. Okay, one more to fill up the it gets I can see someone getting addicted to just like clicking like making these. Oh, there we go. Yeah. Okay. Here. We'll do this. We'll screenshot this and uh we'll save it. Yeah. We'll save it and I'll post it on Twitter. And then I actually uh posted to this guy. Oh, he responded to me. Cool. So let's see. Reply. Uh yeah. Had to fill up collection. Had to fill out my collection. That's a pretty cool one. With the cigarette. But anyways, yeah. I mean, it's some cool stuff. It's fun. It's fun. Minted. So, we're still early here. I wish I got some of these wild-haired ones, but that's all right. Yeah. But we'll see if Nier actually blows up. I don't know if it will. I'm stacking a few of them. But, I'm just sort of looking through this for fun. Just because it's so cheap, right? It's like they have pretty much everything that I don't know. They have NFTs. let's say that. There's probably some pretty decent DeFi projects on here, but I don't know. What would I use Near for? I don't know. I don't know. One of one. Shook guy. This pixel art is killing me. Like, so much pixel art. And it's like pixel art, but like it's the same pixels, you know. It's it's fun, but yeah, this cat dude. he went he went ham on the cats. Oh man. Yeah. I mean, it just reminds me of things like oh, like those plastic character things that people buy, you know, stuff like that. Yeah, the rare plastic, expensive plastic. I mean, it's the same thing, right? Except these are just expensive gifts. It's not for everyone, that's for sure. But you know, I got one of these for free. The man, they did one for every coin, and it's like all he did was put like the logo. See, like these animated ones are fun, right? You at least gotta animate them. I don't know what the heck that is though. Okay, maybe that's enough with the NFTs. Well, let's sort this the other way around. Let's see what the most expensive NFT is. Oh man, that's a lot of money. Wow. These are like resells though, right? Like these are the ones that someone bought for like two or three near, and then you know they're trying to resell them. Like, see, yeah, owners. He like okay. Let's see how much he bought this for. Citizen of Pixels. Oh, is this his own Citizen of Paras? No, yeah, this is just a collector guy. And he wants 9 million near for that. I mean, that's like a billion, right? That's a lot of money. Gorilla Punk. Yeah, it's funny. So, okay, we'll do a. We'll check the wallet. Um, or we need the Near Explorer. Let's explore the dude. Let's see what all he bought. So this dude has this dude has 4.3 near. Okay, created this wallet this year. He bought some NFTs. Um, price. He definitely did not pay uh, 9 million near for that. That's for sure. I mean, he's only spent like a couple cents. Yeah, he's like me. He's a cheapo. Yeah. Anyways, okay, maybe that's enough with the NFTs. All right. Let's see. Is anyone in here? I try to pay more attention to the chat today. Let's see. Oh, stream manager. Okay. Cool. All right. Let's see here. Let's get back to work. Let's see. I'm gonna skip day 2. I mean, we did a lot of day 2, right? Maybe. Probably not. Complete the guided workshop. Fix failing tests and draw some sweet decentralized pictures. Yeah. Review some of Near's data convenience structures. Persistent map. This is the assembly script stuff. Is there Rust stuff? Rust collection types. Vector. Okay. I didn't think this was a near thing. Implements a vector persistent array, can iterate using index. Uses the following: map index to elements. And that seems like a normal array to me. Lookup set. Implement a persistent set without iterators. Cannot iterate over keys. More efficient in read writes. Okay. Lookup map. Implements a persistent map. Cannot iterate over keys. Does not preserve order when removing and adding values. Efficient in number of read and writes. Oh, excuse me. I've been a little tired lately. So, near contract basics Rust. As presented by Evgeny. Maybe we just watch a video today.
My name is Eugene, and I am here with Nir. And today we'll try something new. We'll go through one of our contracts in Rust, and we will review how it's all done. And this is the first session, so let me introduce myself. So I'm Eugene. I work at Nir. I work on runtime and contracts. And let's go next. With me is Mike.
Hey, I'm Mike. I'm a DevX engineer. I've got some Rust experience, but these contracts we're looking at today are going to be new for me, so it's exciting.
I'm Chad, in the same position as Mike, DevX engineer. This contract is new to me. Less Rust experience even than Mike, but like some familiarity. So, Josh, who are you?
I am Josh. I am also a DevX engineer, and my Rust experience is even lower than these individuals. So I'm really looking forward to
this. Is really
more.
Funny.
My name's Sharif.
I mean, so, we've just been through 4 engineers. This is 2020. It's been 2 years. I mean, they probably know quite a bit more about programming in here. So, and they're probably, they're definitely better programmers than I am. So I can't criticize them, but it's kind of funny that they're saying this on a YouTube video where they're supposed to be teaching people.
If I work on education in Near, I can spell Rust confidently. Looking forward to it.
All right, let's start. Let me present my
I mean, to be
screen.
fair, not many
Today
people
we're
are
gonna
experts in Rust.
discuss a voting contract, and this is the contract that was used by mainnet to trans.
Okay, maybe I just watch these on my own later and come back with the knowledge to you guys. Sorry, I'm sure that doesn't sound very good, me moving around my microphone. Okay, so let's just read through this really quick. Excuse me, we just got back from eating pho, so pretty gassy, bloated. It's a big bowl of noodles, if you guys have never had any. Okay, Near contract basics, Rust. Let's do it. Background. The voting contract was used by mainnet validators to enable transfers in October 2020. Wow. What? That was when that video came out. So, okay then. This is significant because it made the network fully decentralized and moved the Near network from phase 1 to phase 2. The transition to phase 2 occurred because Near protocol validators indicated via on-chain voting mechanism that they believe the network is sufficiently secure, reliable, and decentralized to remove transfer restrictions and officially allow it to operate at full functionality. Accounts that are subject to lockup contracts will now begin their unlocking timeline. The shift to phase 2 means three important things. Permissionlessness. With the removal of transfer restrictions, it is now possible for anyone to transfer Near tokens and participate in the network. Specifically, it is now possible for anyone to send or receive tokens, to create accounts, to participate in validation, to launch applications, or to otherwise use the network, all without asking for anyone's permission. This means individuals exchange DeFi contracts, or anyone else can utilize the Near token and the Near network in an unrestricted fashion. Okay. I guess that's a given to some people, but, you gotta think that's maybe not even a given in regular internet, right? Because I know that we block off some access to people. Now, transfer, you being free to transfer tokens. What does this say? DeFi contracts or anyone else can utilize the Near token and the Near network in an unrestricted fashion. Yeah. I mean, the way that they phrase that makes it sound like it's more freedom than it really is. Because I'm sure you still if you wanted to, you can restrict access to certain wallets, right? Or maybe not. I don't know. Like, if you think about an airdrop on on Ethereum, right? If you think about an Ethereum airdrop, you can airdrop to wallets, just to any wallet, right? It's like people who mail stuff, like junk mail, to houses. Like, you have the freedom to send mail to anyone in the world. Whether or not they appreciate that mail, it doesn't really matter, right? You can send them mail and it's gonna get to their house most of the time. with ETH, right? You can think about like Kick. I remember when Kick did an airdrop, they dropped like 888,000 tokens to a bunch of wallets, and the only way to unlock them was to use Kick, and it's like this pyramid scheme type of model, right? And like all those tokens still only worth like $4,000 now, but yeah, it's I guess you do have the freedom to unrestrictedly send near to however you want, right? But I guess, yeah, that sure. Voting. We'll move away from that. Yeah, voting. The community operated. Near Protocol successfully performed its first on-chain vote, indicating that community governance is operational and effective. The exact mechanisms will change going forward, but this is a substantial endorsement of the enthusiasm of the community to participate. Okay. Yeah. I don't know. This whole voting thing. I mean, yeah. Anyways, let's go on. Decentralization. The dozens of validators who participate in the vote were backed by over 120 million tokens of delegated stake from over 1,000 individual token holders. And this vote indicated that they believe the network is sufficiently secure and decentralized to operate freely. 120 million tokens. That's a lot of tokens. Between 1,000 people, though, that doesn't seem very decentralized to me. But I guess that's only 120,000 tokens, right? Yeah. Per person. I mean, how much is that? That's like $1 million per person. I don't know. Who has 3 million near? Maybe we should go on to explore and see who the millionaires are. In essence, Near is now fully ready to build on, ready to use, ready to grow on to its full potential. While Bitcoin brought us open money and Ethereum evolved that into the beginnings of open finance, we finally have access to a platform with the potential to bridge the gap to a truly open web. Cool. Eugene walked us through a contract code in detail. This article attempts to capture the most salient points for developers new to the Near ecosystem who want to learn to write contracts for Near Protocol using the Rust programming language. Near also supports assembly script as a contract development language, and future articles will attempt similar treatment for that language. At time of writing, Near recommends using Rust for high-value contracts, which manage mission-critical features or significant levels of capital due to the maturity of the Rust language, its community, and the vast amount of attention paid to Rust to WebAssembly toolchain. Okay. File system. The voting contract can be found here. The key files in the repository are listed below and will be introduced in this document. So basically, the key files from the template, the TOML and the source Rust code, Rust script, RS file. So, brief note on compiling contracts for Near. A Near contract written in Rust must be compiled as a library. This is in contrast to an executable the kind of program that runs directly on your computer. On Near, contracts run inside of a virtual machine called the Near VM that is optimized to work with the blockchain. Contracts require another program, this VM, in order to execute. Technically speaking, there is no WASM32 WASI target as with typical Rust programs that run directly on the operating system. Instead, Rust smart contracts targeting Near use the WASM32 unknown interface. This creates a file that any runner, like the Near VM, for example, with I don't know what WASI is, but I'll just keep calling it that. Please correct me if you know what WASI is. WASI support can execute as if it's a normal binary. Okay, let's just look this up. I don't want to. WASI web is a modular system interface for WebAssembly. I wish they would tell you how to pronounce it. Okay. WASI. WASI? WASI? Is it WASI? WASI? WASI. Let's see. WASI. Web assembly. System interface pronouns. We'll call it WASI. WASI. Yeah, we'll just call it WASI. If you try to compile a contract for Near on your Rust toolchain, and your Rust toolchain is missing the WASM component, the compiler will report an error similar to this one. Can't find crate for core. Note the WASM32 unknown target may not be installed. This command to add the WASM target to the Rust toolchain. Okay, so I've done that. To develop a Near contract in Rust, there are a few things you will always do. The boilerplate TOML. Okay. And we learned that this is very important. The Near SDK 4.0.0 pre is important. And then the year being 2018 is mandatory, which they don't have a year here, which just shows how out of date this is. But anyways, optimizations to improve size and performance of code. No debugging, this reduces the size of code. Panic aborts. It's important that contracts fail loudly. Yeah, instead of quietly. Yeah. Okay. Overflow checks that forces panics on lower upper bounds, overflows and WASM. Silent overflows can lead to contract abuse, so this increases safety. Yeah, that makes sense. Click to view full voting contract. Oh, you know what? My mouse double clicks all the time. As of July 2020. Okay, so before we go into that, I just want to look at Stack Overflow and see if this guy actually gave me the answer. No, he didn't. Come on. Please answer me. Uh, it might be too old. He'll never answer me. Oh well. Anyways, contract in general, keep in mind that we are operating in a resource contained environment of the near protocol runtime. For any single contract method invocation, all storage and compute operations must fit comfortably within a single block of 1 second, along with any other calls made on other contracts. It's useful to keep this in mind as we design contracts that operate as good and performant citizens of the network. You can read more about thinking in gas in our other docs. Yeah, I was on the wallet today. Was I on the wallet? Yeah. I was on the wallet. I was looking at my my NFTs. I got some more. Nice. And if you look at these actual counts, right? Look how little storage they're using. I mean, that's just crazy, right? Like, they have thousands of pictures on this website, and it's not even using a gig yet, which is wild to me. I mean, they've done 2 million transactions. That's crazy. And then 41 out. I wonder where that out goes. I wish you could sort by anyways. I mean, and if you look at like chain punks here, like kilobytes, that's crazy. They've only had 240 transactions, so the first 150 of these were free, but and he only has 12 near on this wallet. That's crazy. This guy has 6,000. Yeah, so he has $60,000. I mean, that's not bad. That's like a year's salary, right? Yeah, I mean, it's good. That's good. Dude has $97 from chain punks. I mean, he's only selling them for like $2 a piece, right? So that's pretty cheap. I can't say much. I don't have that much. But I didn't, I'm not stacking on my wallet. I'm on an exchange. I know. It's not good. Yeah. It's my NFTs, boys. Okay, anyways. Let's get back to the groove. Okay, contract. So here's the actual lib.rs. So in general, keep in mind that we're operating in a resource, for any single contract, Also surprising for some new to contract development, the concept of randomness and time are not available on the same terms as when running on bare metal. Randomness is especially tricky. The only real authority on time is, in this context, is the blockchain. So any notion of time here is tied directly to epochs, especially epoch height. The Rust SDK also exposes inv random seed. Yeah. And I can see how you would want to develop your own time right? Because that simplifies the web experience across uh, across countries, right? Because if you think about how difficult it is to uh, deal with time zones, there's probably some guy at Meta, and his whole job is to fix time zone issues uh, for certain people, right? And so if every machine's time is based off of uh, the blockchain, then that just is one thing you don't even have to think about anymore, right? And we do live in like such a interconnected world. Like, of course, I could have a problem at 11:30 Eastern, but you know, if I told someone in France 11:30, it wouldn't be the same thing, right? So, um, yeah, when you're talking about blockchain and you can give a number that's the same for everywhere in the whole world, that that just makes things so much easier. You're always talking the same time zone, which we use time zones because I don't know. It's like, yeah, I mean, it's nice that like 12 noon is like when the sun is directly above your head, but does it really matter what we call noon? Like, could we call it 3 o'clock and it would be the same thing? You just have to get used to like what time is what time, right? I don't know. Either way, let's move on to line 1. Near SDK RS provides support for writing performant contracts, including a custom binary serialization deserialization format called Borscht for storing contract state efficiently on chain to reduce both storage and gas costs. The first line of the contract brings these tools into scope. So use near SDK Borscht self, Borscht deserialize, Borscht serialize. Yeah. Yep. We saw that. Line 2, reading on clients of the contract, many may require a JSON format for argument and return types. Since JSON is limited to JavaScript number support, 10 to the 53rd, we need to wrap Rust U64 and U128 with some helper functionality that returns these numbers as as JSON strings. Notice the difference in the U on wrap types versus the lowercase u on Rust native types. Interesting. Okay, so yeah, that makes a lot of sense, I guess. So JSON uses JavaScript typing, so you need to use a JavaScript wrapped integer, unsigned integer. Okay. Oh, sorry. Still tired. I should drink like a tea or something. I don't know. Near SDK RS. So, let me drink some water. Okay. Exposes the virtual machine execution context through INF, which developers can use to integrate the near runtime for information like the signer of the current transaction, the state of the contract, and more. Near bindgen will be explained where use lower in this document, account ID, balance, and epoch height are all types that are native to near protocol and represent what you expect them to. Check out the near source code for more details about types like account ID. Yeah. An account ID, you're always, I feel like I'm always asked what the account ID is. So I feel like that's something that you kind of expect from the user. Okay, line 4. When choosing, so we're still, I think, okay, so let's download this so we can look at the code while delete directory. What? Okay. Oh shit. There's a lot of stuff there. What? Yeah, let's just put this on this. Let's just open this up. I have no interest in this circle problem. I'm sorry. I'm not good at figuring. I don't know. I mean, I figured out a little bit of it, but I debugged 2 of your things. It's like a puzzle that I just don't feel like figuring out. Open folder. It's on my desktop. When I'm streaming here, I feel so exposed because I'm showing like my whole computer. I should maybe not do this every time, but I don't know. I don't have anything to hide, so just my anti-Russian affiliate links and let's see. What am I looking for? What is this thing called? Core contract master. Yeah. So let's open that. And then this is in voting. And we're looking at the source libs. Yeah, so this surely has changed. Yeah, it got updated. Oh, wow. This hasn't changed in 2 years, so there's that. Okay, so yeah. So, they literally started at line 1. Yeah, and we're just importing what libraries we need to use, which I guess, yeah, you have to import the JSON types. Okay. Yeah. Okay. All right. So near SDK. Oh, hey, someone's following me. Thanks. I'll Richerso Di Bruno. Let's see here. Line 4. Oh, yeah, line 4. When choosing to organize how data is stored in your contract, it's important to first decide whether you want to use key value store or singleton storage. Okay, so key value store is a key value structure, which is ideal for managing large contract state or cases with sparse access to contract data. So, i.e., you only need a few pieces of data on occasion. Okay. This state is only deserialized when you access the otherwise, when accessed and otherwise remains untouched. The contract will store directly using the storage interface and or choose a more appropriate abstraction from among the list of available collections, like a persistent vector or unordered map. Okay, that seems pretty secure. So what's the singleton then? Singleton storage is a serialized representation of the contract struct. Using this type of state storage, is more efficient when contract data is small and known to never risk growing unproportionately large, and when read operations on the data are frequent. Okay. This first one is concerning because I don't know when to expect things to grow unprecedentedly large. Like, what can my contract or whatever in my contract just like get bigger without me realizing it? Have they had this problem before? Or is this just hypothetical? I mean, it's number one, so I feel like that since the state is deserialized in its entirety, every time a contract method is called, it's important to keep it small. Okay. The choice of the STD collections hash map here hints at a Singleton storage strategy. Maybe it's always deserialized. See, this sounds more secure and seems like the way you should do it than this. If you're just going to leave it unhashed the whole time, like why even hash it or serialize it, right? The key value structure, which is ideal for managing large contract states or cases with sparse access to contract data. See, and I'm thinking in terms of like NFTs, right? Like if I go to Para's, okay, I'm using this website, but I'm not accessing the contract. So I assume that this part of the interface is just your standard HTTP website. It might not even be hosted on the blockchain, right? But then when these are being hosted on the Okay, so maybe these are like a deserialized contract because you have to like you have to get the information about the actual NFTs all the time. So maybe I wonder. Okay, yeah, and so this is on this Mara smart contract.near. This is on Mara, and this is on Mara's, and so you request the information from the blockchain and present it on this website, right? And you do that so many times, you might as well, and that's public data anyways, so you might not even need to, serialize it at all. But then when I log into the, when I purchase something here, or when I log my key into it, it has to deserialize my information. Well, I mean, that's public too, but how does it know that I'm me? So I guess it would have to deserialize like some sort of confirmation cookie or something that says that I'm like the actual owner of this wallet. I don't know. We'll probably learn about that. So this is probably key value storage. If I had to guess, this is probably for when you personally are interacting with the blockchain to purchase something. you probably want to use key value storage. But then, or when you're doing like DeFi stuff, right? But when you're doing something public, like an Explorer, or you're showing like an NFT gallery or something like that, you probably would use a Singleton storage. Yeah, I think that's how I read this, at least. Pressing on. So line 6 through 7. Yeah, here. Okay. Rust allows us to define our own custom memory allocation mechanism to make memory management as efficient as possible. We alloc. I forgot what. I guess you have to allocate. So what's we? What's the we part of this? WASM enabled Elfin allocator. Elfin, small. Elfin generates less than a kilobyte of uncompressed WebAssembly code. That's small. Doesn't pull in the heavy panicking or formatting infrastructure. We alloc won't bloat your WASM download size on the web. WebAssembly enabled. Designed for WASM 32 unknown target. Okay. Let's just look up alloc real quick, because I'm kind of not sure what that is. Alloc. Rust. Okay. Memory allocation API. Allocator. An implementation of allocator can allocate, grow, shrink, deallocate arbitrary blocks of data described via layout. Okay, so we alloc. Oh, I get it now. Okay, it's like an Irish thing, like okay, yeah, like we lad, but it's we alloc. But we stands for WASM enabled Elfin, which they use this word just to make it spell we. Yeah. Yep. Developers are funny. Has good performance when compiled. Yeah, that's what they say. And in contract, we alloc would be a poor choice for a scenario where allocation is a performance bottleneck. It's small, less than a kilobyte, but doesn't have good performance as a standard allocator. In fact, it is a O of n in is an O of n in the number of allocated objects. Yeah, so I believe that's linear. Yeah. Yep. It's safe to consider these lines boilerplate and just include them in your contract without much thought. If the choice of allocator changes for some reason, you'll probably hear about it. Okay. Yeah. Okay. Global allocator. Okay. Yeah. As mentioned earlier, Near SDKRS provides wrapped types that allow contracts to return JSON compatible formats for big numbers. These types are required when contract methods return large numbers to a JavaScript execution context like the browser. Internal calls ignore these types and use native Rust types as usual. In the following case, the original something is a type of U64, but we want to make sure that we can serialize and deserialize it in a contract boundary when communicating with the outside world. So we wrap it by using the type U64, the uppercase U, the same type, but with conveniently automated serialization requirement for any contract method argument. Okay. Because it has to be in JSON format. Everything in Near so far I've seen is straight up is JSON. You know, so at least all the contracts, all the requests, the blockchain is in JSON, which is, I don't know if that's unusual or not. Let's see. Near Explorer. I mean, so let's just look at the Ethereum Explorer. Okay. Oh no, I just want to see just some random transaction. Right? So like, damn, this is like hard to read. So this dude just like was using Uniswap tag StepFi. See, and I don't really know Ethereum very well, but like, you know, I don't get how yeah, so this is a contract, but where's the contract info? Like, is it just, I don't know. Right? It's just numbers and hashes. But you look at Near and you know, like these transactions are so easy to read. You're just like, oh, it called, this guy just unstaked his contract. Cool. He transferred this to this monkey guy. Like, this is so clean and easy to read. This is like, what is this? This dude has so much. Okay, well, these are transactions, but like, what are you doing here? What are these transactions? I don't know. Input data. What? This is hashed even, or what? I don't know what this means. You know, it's encrypted. Yeah. Maybe my face is blocking that, but like, what is this hex code, you know, stuff? I don't know. This is easy. Like, oh, okay, this guy like bought an NFT from the monkey guy. That's actually pretty cool. Let's check out monkey. Like, the monkey. I don't know why everyone loves monkeys all of a sudden. Let's just Google him. The monkey here. Okay. Yeah. Okay. Second gen, then third gen F. Oh. Why adopt a monkey? Ownership of your monkey for commercial or personal use. Nice. Enter the habitat. Yeah. I mean, should I log in? You have no coins to claim. Please wait for... Oh, that's interesting. Maybe I'll come back tomorrow and claim some coins. What is this? Okay. I hear ya. You want your precious Pisang coins? First generation monks can earn 3 coins per day. Coins are stored in a basket and hold a maximum of 21. 7 days equals 3 coins per monkey. Coins for each monkey for each week, or put it another way, a maximum of 3 coins per day per monkey. You can also earn Pisang coin through various other methods, for example, completing missions on the Monkey site. You will be rewarded the Pisang coins. Pisang? Is it Pisang? I don't know how to pronounce this. All monkeys. Should we get a monkey? These things are freaking expensive. Jeez. I don't know if I want to buy any of these, honestly. Average price is 4.79. Floor price is 2.5. What? Why are these so popular? 200 for this clown monkey. Oh my god. 555. That's $5,000 for a monkey. That's so crazy. I don't know. See, it's a little slow loading these guys. You know, it's, like, I have gigabit internet. Like, you know, this isn't my internet. It's just the loading from the blockchain is a bit slow. I mean, it's not unbearable, right? But man, generation. Baby monkey, super monkeys, human monkey, original monkeys. Okay. Okay. Well, anyways, yeah. See, like, you can learn about stuff just by looking at the. I don't know what any of this is. I don't know what these contracts are. I mean, maybe they're just transactions. Who knows? Maybe we just have to... Oh, maybe here's... Is this a smart contract? Like, how do you know the difference between smart contracts? I don't know. Maybe I should look into learning Eth also, in addition to Near. But yeah. Anyways, I do like this. Even though there's been like a lot of problems, not a lot. There's been 1 or 2 big roadblocks since I've started doing this, but I do like, this is definitely like made for developers, right? It's so easy to read, it's so clean. It's just, the code makes sense too, I think. Although I haven't tried Ethereum or anything like that, so let's just keep going with this. I'll start my first. We'll get this Near developer thing, and then maybe we'll try a different blockchain just to compare how they work. Wrap a Rust struct in Near BindGen, and it generates a smart contract compatible with the Near blockchain. That's it. Every Rust contract struct must be preceded with the macro, since it exposes the execution environment to the contract, which allows it to receive method calls, send results, and generally behave like a contract within the runtime environment. Each contract has its own singleton storage as part of the contract account, where the contract state will be serialized and stored on chain. Inspecting account storage will reveal a key named state whose value is the singleton storage. Okay. The following lines define the struct, which will become the singleton representation of the contract. Only one public struct should be decorated with the near bindgen macro, along with the implementation of the struct. Contracts are efficiently serialized using Borscht, the binary representation described earlier in this document. So 2 macros, and then the public struct for your contract. Okay? And that's where, okay, let's look at this. So where are they storing in here? The epoch height, the wrapped timestamp. When voting ends, none means the poll is still open. Okay. The balance, voted balance so far. And then here is how each validator votes. Okay. How much each validator votes. Okay. It's just weird to think that like everything is based off of like balance, like monetary balance. It's weird to think that, you know, everything that you do will, or you can only do things if you have the money to do it. You know, and there's not going to be anything that's free. I mean, maybe it's free, you know, in the long term, because you'll get your money back, because, you know, voting is free, right? Because you can stake as much as you want, but and you'll get it back after the voting ends, but, you know, it's not free because you have to have money to stake to begin with. So it's weird to think of Web3 in that sense, because really, you know, what's mostly been advertised about Web3 is the fact that it is decentralized, and the data is available for everyone, but it doesn't mention that in order to manipulate the data or change the data, you have to have money, right? And so is that decentralized? I mean, definitely no, right? Because if you think about the decentralization of the capability to access and change data, is still in the hands of people like Elon Musk or something like that. So the data itself might be decentralized, and stored in, you know, all over the world, and is verified, but the people who can change that data, they're the people with money, right? That part, the decentralization of that part doesn't change. Which, it's interesting to think about a internet where you have to have money to do stuff. But maybe that's the wrong way to think about this. And maybe there's something to be said about this method of transaction, because people will say that, this code builds on value, but it's only, or it's like capitalism to the max, right? Because every transaction costs a little bit of gas. And so you have to think about what you're doing very carefully on the internet. You're not just clicking on things and downloading things. You're thinking very deliberately about what you're doing, because you know that everything that you do is going to cost a little bit of money. So, in that sense, people have to, be more careful about their actions. And so, I don't know. I don't know if that's advantageous or not for the web, where people are more deliberate. They're not as exploring, right? I don't know. Let's keep going, and maybe by the time we actually are able to create our own contract, we can have some answers to these sorts of questions. Like, what is this for? What can we really do with this? What does this enable us to do that a traditional web, can't do, because people are too loosey-goosey, people are too freewheeling. Anyways, okay, so line 16 through 23. And that's going to be from, oh man, this is a lot of code. 359 lines of code. Oh my god. 360 lines of code. If you call this, you gotta count the last line, like 361 lines of code. Anyways, and we're only on 16 through 23. But this ends at line 34. They don't talk about, a lot of these are tests, huh? Okay, that makes sense. Because you do want a lot of tests if this is the voting system. But still, like, the tests start at 129. So there's a lot here that's not explained. He explains up to here, basically, the implementation of the voting contract. And then here are just the functions that come with, these are the functions that you can call, and some of these cost money and some of these don't. Yeah, this makes sense to me. I think I might be able to write one of these next week. And I think I'll set my goal for that. Like, by next Friday, I'm going to have a Rust near contract, smart contract. All right. As long as I can get through this freaking tutorial. God. Excuse me. Within this contract struct, we can store any Rust type. This contract includes an example of storing a map of custom types with the hash map, specifically mapping account IDs to some related balance. It also includes an example of storing a custom type exposed by near SDK RS. Okay. It also includes an example of storing a custom type. Okay. Yep. Called balance. Wait, what? This contract includes an example of storing a map of custom types with hash map. Okay. This is a map of custom types with hash map. Or you can store a custom type but exposed by near SDK RS called balance. An option type, meaning it may or may not have a value, and the epoch height for keeping track of time from within the context while running the blockchain as mentioned above. Okay. So, I think he means this one, right? So option, like wrap timestamp, like this doesn't have to have a value, which makes sense because it seems like it's either, if it has no value, then the poll is still open. And then when the poll is open, it probably says something like poll is closed. And this, or it sends the time, like it's this time. And if that matches the epoch height, then you assume that the poll is closed. Or if you receive anything here that's not none, you assume the poll is closed. But you can probably check this to this or something like that. Because I don't know why they would call it a timestamp if it wasn't a timestamp, right? Which, it wouldn't make sense to use a time that wasn't based off of the blockchain time. That would be so weird. Because, then you would have to think about validating like NTP servers and stuff or something. But anyways, what if there was a blockchain time oracle? That's interesting to think about because, we have all these NTP time servers all over the place. And, what's that time based off of? Maybe some some atomic clock in Sweden or something is like the GMT, UTC time. That's the global universal time that every computer server is based off of. But if you decentralize time and you counted time based off of some sort of near oracle, it's like Chainlink, but all you do is like keep track of time. Time link, time cubes, time crystals. Yes, time crystal blockchain technology. Okay. Anyways, maybe that's a thing. Who knows? I mean, so again, let's look at this. Okay, so like where's this time come from? Like this 1 minute or this. Okay, so I mean, timestamp of this transaction was submitted, docs. So there is like a timestamp thing, right? Like public key. I don't know. Well, we'll think about that. That could be a cool project. That'd be like fairly simple to do, because time is pretty important. And no one wants to do the boring stuff, but that's the stuff that really matters. Like chain link. I'm going to shill chain link for a second because chain link matters. Oracles matter, right? Because everyone has to know what things cost, or people are going to get ripped off. I mean, of course, you can always charge a transaction fee, but you don't want to overcharge people like 50 cents per token. That like adds up, right? Like everyone should have the same price for the price of crypto, and it should be all based off of one oracle, like Chainlink. It's just not fair, You can't undercut. Maybe you can. I don't know. Anyways, lines 26 through 30. So we're out of the struct now, right? Yeah. We're in the actual implementation. And I don't know if that's what this actually means. So I'm just going to Google that real quick. Rust. Okay. And yes, I know. I don't use Google. I use DuckDuckGo. Anyways, implement. Some functionality for a type. The implement keyword is primarily used to define implementations on types. Inherent implementations are standalone, while trait implementations are used to implement traits for types or other traits. Functions and constants can both be defined in an implementation. A function defined in an implementation block can be standalone, meaning it can be called foo bar as the function takes self and self or mutable self as its first arguments. It can also be called using method call syntax, a familiar feature in object-oriented programming. Programmers like foo.bar. So, there's your struct. It's called example. It has a number that's say 32-bit integer, and then your implementation of example has a function called boo that prints boo. Example boo was called, and it has a function answer that takes a mutable self where self dot number is plus equal 42, and then it has a function get number self that returns a 32-bit integer, and that's the number. So trait thingy, fn do thingy and self. Okay, and so yeah, and you can okay, yep. You can call this number here with self.number. That's all it's saying. Okay, and this just returns the Yep. Okay. I think I get it. So here, the implementation default for voting contract. And then they did the struct for voting contract up here, right? And it has a total vote stake, result, last epoch height. And so in here, you could theoretically do something like, I mean, of course this returns self, but you could do like a function, uh, add balance or something that returns a I guess balance. What is balance? It's a U128. So that returns a U128 that what? So I can't do that? I don't know. Oh, here's the voting contract. I don't know what default is. So here you could do one that's like, oh, not in there though. Yeah, you could do one that's like U28 returns you could do and new itself. I don't know. We'll figure it out. Let's just finish this. Okay. I think I got it though. You could do like a self dot. Well, obviously you can't do it here. I don't know what this default for. We'll figure that out later. By default, all contract methods. Okay, this bit of code is part of a larger context where we have decided to control contract initialization by decorating a specific method with the init macro. See below. By default, all contract methods will try to initialize contract state if not already initialized, since it's possible to call any public method on a deployed contract, but in this case we want to avoid that behavior, right? So that's kind of like the meme museum actually comes into play here, because you have to become a contributor of the meme museum before you can upload memes to the meme museum. So here they want to do the same thing, where you have to join the voting contract before you can vote, because anyone can call the methods on the voting contract, but they don't want you to vote unless you've registered to vote first. And that makes a lot of sense. So here, default, self, environment, panic, this is a string. Voting contract should be initialized before usage. Okay, that makes sense. Decorating in an implementation section with the near bindgen wraps all public methods with some extra code that handles serialization, deserialization for method arguments and return types. Panics if money is attached unless the method is decorated with hashtag payable and more. Okay. Panics if money is attached unless the method is okay. That makes sense. Because you don't want to take people's money by accident or whatever. You need to explicitly say, like, okay, this implementation can will interact with money. Yeah. Near bindgen, and then you implement your voting contract. So this here is like a pre like in like in React, you can, oh, I already forget what it's called, but you can check to see if data is loaded, right? And so this is like a pre-run, and then here's the actual implementation. And here's the last lines that it goes through. So decorating a public method with init will add some machinery to the initialization. Yep. I mean, that's what it says here. So init will add some machinery to initialize the contract by serializing and saving the return value, in this case a struct, into the contract singleton storage. You can add an init decorator to any public method to mark it as something like a constructor for the contract. Note that there's nothing special about the new method name here. It could just as well be old, and that will work fine. New is a convention used by Near community because it sets the correct expectation for anyone reading the code. Okay. The implementation references environment state exists to assert that the contract singleton storage state has not been initialized, i.e., it does not already exist. We don't want to accidentally reinitialize the contract at some later time and blow away any valuable state that has been captured. The init macro expects that the method method it decorates will return an instance of the struct, which is being referenced by this implementation section. The return value will be serialized on chain into the contract singleton storage. If you're new to Rust, then you may not be familiar with implicit return, a language feature likely passed down through the influence of Ruby. It allows the last line of the method to be assigned as the method's return value. In Rust, we get an implicit return of the value of the last line of the method. If we just ignore the semicolon, at the end of the last expression, in this case, the last line returns an instance of the voting contract with all attributes of the struct initialized to their default values. Rust calls these expressions rather than implicit returns. Okay. So these are expressions. Assert state. Contract is already initialized. Now, note that the method signature of new is returning an instance of self. Yes. But could just as well have been voting contract, except this way we have to change fewer tokens in the code if we ever decide to rename the contract. A modest but meaningful gift to our future selves. Okay. Yeah, so you initialize and then you check if there's a contract, and if there's not, then you say that if there is, then you say it's already initialized. If it doesn't, then you initialize the balance and the account ID, and then you set the total stake to 0. You set results to none because that means you can still vote. And then you set the last epoch height to 0. I don't know if that makes sense to me. Doesn't that indicate like the start of the blockchain? Shouldn't you actually call for the last epoch height to make sure what it is? Yeah, so I think this makes sense. I think that's what that means, right? I don't know. Maybe I should learn a little bit more Rust before I start writing this. But I still have until next Friday to really uh, get a better understanding of this. Let's see. I have like 20 more minutes of streaming left. Let's do I want to go over these other features? I don't know. Let's see what the next steps in day 2 are. What did I do with that thing? Oh man, I have too many windows here. What's this, Figment? I want to try the Figment stuff. I don't need this Rust before day 1. Let's see, writing. Let's see, testing. Learn to write unit and simulation tests. Deploying, demonstrating Web3. What's the group project? What's the end goal of this? Core activities. Capture your demonstration using slides and videos. Present your work in 5 to 10 minutes to the group on Friday. Celebrate a week well done and welcome to this side of that. Okay. Deploying Web3. So this whole time, are you supposed to be writing a register your demo spot? So watch the orientation video about today's challenge. Deploy at least one application to testnet. Okay. I guess you should write a application on day 2. You should test it on day 3. You should deploy it on day 4, and then you demonstrate it. So, I guess I should have this written then by this one. I mean, I feel like if I wrote something today, it'd be a lot of copy pasta, for sure. Let's look at these NFT things. It's literally all look the same. So it's funny because all you do is write one page of code. I mean, I guess you can like break this up a little bit, right? And put it into different pages, make it easier to read. That's probably worth it. I mean, I feel like, it's weird that the tests are all on the same page. But maybe not. So here's the bind gen NFT metadata get unwrapped. I don't know what I do. What kind of site do I want to make? Would I do like I don't know. I kind of want to do um, kind of want to do like a cybersecurity type of um, crypto project where you're working with indicators of compromise and you're posting them, sharing them. I think that'd be really cool. Blockchain indicators of compromise, but maybe so the files can't be too big. I mean, they're just gonna be like short little URLs or things like that. And I could see, well, I don't know, a really long URL might cost too much money, honestly, to transfer. Maybe I don't know. I'll have to sit and think about like what kind of project I would want to do. I think, yeah. Oh, yeah. We'll see. Anyways, I think I'm going to cut this one short. A couple minutes. I'll see you guys.